that is so while we do groundwater quality reporting, so in that very important component is the spatial and temporal variation, right? So for spatial and temporal variation, हम लोग उसको presentation के लिए we apply different techniques, right, for the presentation of groundwater quality data in hydrogeological report. Admit Kumail as well. So just I am taking DH5 in place of DH6, right? Because there are few topics left in DH5 I want to complete. If you have any difficulty or something, of course I will give you the notes. But if you have any difficulty, just ask me after the class. Or you can ask me in the middle of it. Right. So this is how the groundwater quality data looks like. Right. अब ये groundwater quality ये का data है. Let me quickly show you how we go on what kind of statistics. I have thousands of files opened. तो ये सिंपल स्टैटिस्टिक्स है. फॉर एग्जांपल ये आपका डाटा है. नाउ इसमें यू कैन गो फॉर मिनिमम, मैक्सिमम, एवरेज वैल्यू, स्टैंडर्ड डेविएशन, so these are quite common statistical parameters. So minimum we can, maximum, average. It is visible?
Yes, sir.
Standard deviation. So this is how you will get the basic statistics of your data, right? So you go on to explain that against each parameter, what is minimum and maximum value. At the same time, you can also describe whether it is in line with the geology or rest of the neighborhood area, or it is characteristics of that water type, or it is something unique in that water type. For example, the uniqueness. Can you tell me uniqueness in this? Now, for example, pH is 11.67. This is very, very unique, right? You will not get it in groundwater, but I got it somewhere, so I kept it for the purpose of explaining. So pH has its own, role in groundwater chemistry to play, right? You will read in some other unit that pH influence the mobility of heavy metal. Right. Now average 8.6, which is alkaline. Water is alkaline, right? Then standard deviation. Now standard deviation is how the values are deviating from an average value, right? So you will see that the bigger standard deviation means that there are quite dissimilarity in the data set, and less means there is a uniformity or less dissimilarity, right? So this is one way, and there is also one thing called Pearson correlation coefficient. So Pearson correlation coefficient we applied and we got this table. This table tells the correlation between individual parameters. For example, pH. Now pH, with pH, of course it will be highly correlated. I mean, this is pH against pH. Okay. Now pH is not having any positive or significant correlation except bicarbonate. You see, pH is having a significant negative correlation with bicarbonate. What does it mean? This means, yes, Shaibaz, what is negative correlation?
Yes, sir.
Negative correlation.
Sir,
ये बहुत सिंपल सी बात है. नेगेटिव कोरिलेशन क्या हो सकता है? I mean, पॉजिटिव कोरिलेशन.
जब कोरिलेशन, हाँ, जब कोरिलेशन का 1 होता है तो मतलब दो वैल्यूज एक साथ में मतलब चल रही है, एक बढ़ रही है तो दूसरी भी बढ़ रही है. नेगेटिव कोरिलेशन में सर उल्टा होता है.
हाँ, पॉजिटिव कोरिलेशन तो ये है कि दे आर इंक्रीजिंग विद टुगेदर, यानी आई मीन दोनों की कंसंट्रेशन एक साथ इंक्रीज हो रही है. दिस कम्स आउट टू बी अ पॉजिटिव कोरिलेशन. लेकिन वहीं एक की कंसंट्रेशन बढ़ रही है और दूसरे की घट रही है. सो दिस इज कॉल्ड नेगेटिव कोरिलेशन. तो पीएच के साथ बाइकार्बोनेट कम हो रहा है. जैसे जैसे पीएच इंक्रीज होता है बाइकार्बोनेट उसमें उस सैंपल्स में कम हो जाता है. तो दिस इज कॉल्ड पियर्सन कोरिलेशन कोएफिशिएंट. और ये बहुत ही इंपॉर्टेंट. ईसी और टीडीएस is showing very positive correlation, 0.99. Why? Because EC is nothing but TDS. EC को आप मल्टीप्लाई करते हैं 0.7 से, कांस्टेंट से, तभी ना TDS आता है. ठीक है. So anyway, I am trying to show you the positive correlation. EC, what is EC? EC is the collective measurement of the solute or the suspended solids present in a water sample, right? So TDS and EC will be proportional. और TDS क्या है? TDS है cumulative sum of all the major cation and anion, right? So इस तरह से इसमें आपको ये भी you can describe that TDS के साथ Na, NCA, NCl and SO4, they are forming a positive correlation here, right? So this is how you describe the statistical significance of a data set. Okay, so this is Pearson correlation coefficient. Let me go back. अब इसके बाद होता है concentration plots. Concentration plots are simple distribution pattern contours in the study area. मसलन जैसे वाटर टेबल कंटूर मैप हम ड्रॉ करते हैं, उसी तरह से कंसंट्रेशन कंटूर मैप भी हम ड्रॉ कर सकते हैं. फॉर एग्जांपल TDS कंसंट्रेशन कंटूर, chloride concentration contour. I could not bring you actually the सर एक डिप्लोमा वालों का है ये. अभी हम आपको let me show you actually. Let me show you. Don't go away. Concentration plot से समझ आ रहा है कुछ? आज का? It is very simple. I'll show you actually. My screen is shared?
Yes, sir. सर रिसर्च पेपर में देखे थे कंसंट्रेशन प्लॉट.
एग्जैक्टली
रिसर्च पेपर में.
ठीक है, वेरी गुड. फॉर एग्जांपल ये देखें. अभी तक तो आप लोगों ने यानी वाटर टेबल कंटूर मैप और पोटेंशियोमेट्रिक कंटूर मैप ये ड्रॉ किए हैं. But on the same way, with the same principle, we can even plot the TDS concentration contour. So, अब इस मैप को हम स्पेशियल डिस्ट्रीब्यूशन ऑफ TDS मैप भी कह सकते हैं और TDS कंटूर मैप भी कहते हैं. So, what we can extract from this? If I ask someone, let me ask someone, Abdul Khalid. अब्दुल खालिद.
यस सर.
अब्दुल खालिद, आप ये बताएं, आप एक्सप्लेन करें. I mean, you just need to describe this distribution pattern. What is this basically?
Sir, this is the distribution of TDS.
Distribution of TDS, very good. इसमें कोई पैटर्न नजर आ रहा है?
सर ये लैटिट्यूडनल वेरिएशन है
इसमें वेरिएशन है. तो आप उसको वेरिएशन की डायरेक्शन बता देंगे कि वो डायरेक्शन है. कुमेल.
Yes sir.
So what is the direction of the variation और किस तरह से change हो रहा है? There is a gradational, you see, gradational change in total dissolved solid. किस तरह से change हो रहा है? North to south. North to south, or ये change, it's a big change actually. It's a very big change. I mean, right from very fresh, not very fresh but fresh. I mean 1,333 milligram per liter. Say आपको 21,000 आपको milligram per liter change हो रहा है total dissolved solid. So this is a very big change, right? Same time, as a hydrogeologist, you can describe the geological or land use control on this change. You understand what I said? जो ये change हो रहा है, ये क्यों चेंज हो रहा है, ये आपको डिफाइन करना है एज योर रोल एज अ हाइड्रोजियोलॉजिस्ट. तो क्या रोल, क्यों चेंज है, इतना बिग चेंज कैसे हो सकता है? टेल मी शहबाज.
Yes sir, sorry sir, can you repeat the question please?
Sorry
sir, the question sir, can you repeat it please?
नहीं, मैं पूछा था ये जो इसको हम डाटा को डिस्क्राइब कैसे करेंगे? आई मीन जिस TDS मैप को हम डिस्क्राइब कैसे करेंगे? सबसे पहले तो सवाल मेरा ये है.
सर हम बता सकते हैं कि किस तरह से TDS स्पेशली वेरी कर रहा है एंड हाउ विद डिक्रीजिंग लैटिट्यूड द TDS इज इंक्रीजिंग एंड.
ठीक है, ये तो बात हो गई. What I was telling also that you need to integrate it with the geological map, geology of the area, whether there is a variation in the geology, there is a type of aquifer, or there are certain land use which is affecting or which is causing actually this much of change, right? Or this may be that on the south, farther south, there may be sea, right? Or in the southern portion, the water is mineralized because there is a gradational change or there is a geological change, right? Or I mean, what I'm trying to say that you need to describe the spatial distribution of any parameter. Here in question it is TDS, it may be chloride, it may be nitrate, right? So जो भी concentration होता है, you integrate, you try to explain with the help of general lithology or the geology of the area. For that you need to know the lithologs and which aquifer actually you are sampling from, if there are multiple aquifer system. So यहाँ के ऊपर एक suspicion ये भी है that this may be from the second layer of aquifer or third layer of aquifer in the south, which is more saline, than north part of it. Okay. So let me go back again. So these are the concentration plot, right? अगर हम nitrate का concentration plot करेंगे, so उसकी क्या significance है? That nitrate comes from either from the irrigated lands or from the septic leakages. So that is how we try to integrate groundwater quality with land use pattern or the geology or any other feature which can be correlated. Okay. Again, in this groundwater quality reporting, we go for hydrochemical evaluation. Hydrochemical evaluation के लिए we need to convert the data from milligram per liter to milli equivalent per liter, right? That conversion is done with a conversion factor, and conversion factor comes with the valency divided by atomic weight. So, for example, this figure, you must have encountered this figure in your MSc practical, right? So, with this, you multiply, for example, this is constant for sodium. So, sodium value given in milligram per liter will be converted into milli equivalent once you multiply with this conversion factor. And this conversion factor is nothing but it comes from the valency divided by atomic weight. Valency of sodium is 1, atomic weight is 23. So this is how you get this conversion factor. अच्छा, ग्राउंड वाटर क्वालिटी वेरिएशन को एक्सप्रेस करने के लिए वी हैव अ नंबर ऑफ प्लॉट्स. फॉर एग्जांपल, यू हैव गॉन थ्रू ट्रिलिनियर पाइपर डायग्राम, पाइपर ट्रिलिनियर डायग्राम. इन द सिमिलर मैनर अप्रोच सेम है सभी का. LL Langelier and Ludwig plot is also there. Duro plot, which is extended version of Piper trilinear diagram. Schuyler plot, USSL is for irrigation, Wilcox is for irrigation, stiff diagram is for general quality, Gibbs is for genesis. I mean, whether it is evaporation or rainfall is a factor in groundwater quality. And we have XY plots. Right, so we'll go through these plots. Maybe in the lab, in the next semester, we'll go some of it by Piper you have already gone through, and some of them you will go through in your next semester. Or okay, so let me quickly come to the water quality indexing. अब ये fourth component हम discuss कर रहे हैं reporting का, जिसमें कि 3 ऊपर के components थे. उसमें statistics थी, spatial distribution था, और third था जो classical diagrams हैं, for example Piper. So उनके जरिए हमने ग्राउंड वाटर क्वालिटी को एक्सप्लेन करने की कोशिश की. ठीक है, ग्राउंड वाटर क्वालिटी में उसका इवेल्युएशन, उसकी जेनेसिस, दैट जैसे कि पिछले लेक्चर में हमने पढ़ा था दैट ऑलमोस्ट ऑल ग्राउंड वाटर ओरिजिनेट्स फ्रॉम रेन, एंड रेन का जो TDS होता है वो बहुत लो होता है. रेन के और जो पैरामीटर्स हैं वो बहुत ही कम होते हैं, बिकॉज इट has gone through a process of evaporation and condensation, right? Once it came in contact with the surface, so through runoff and percolation, it came in contact with the material, soil and aquifer material. Prolonged interaction mineralized the groundwater, and we took the sample, we take it to the lab, and from there we started our today's lecture, right? So this was the lab and assessment of the groundwater samples. Then we start our reporting. Okay, so very important component of the reporting is that what is the quality? What is the quality? And we analyze that quality for different criterias. Criteria could be defined by the competent authority, and of course it run by some objective. So there could be these three general objectives: selecting benchmark, guideline or standard that are appropriate in assessing groundwater quality for human health. Okay, so your department will select the benchmark or the guideline or standard, right? So we in the last turn हमने बताया था that United States Environmental Protection Agency or WHO or European Union. So these countries have their well-defined standards for different usage, including drinking water. But for developing or underdeveloped countries, they directly adopt the WHO standard. Right. Selecting parameters that have an appropriate benchmark and have reasonable global coverage. कौन से पैरामीटर आप सेलेक्ट करेंगे? ठीक है, सोडियम क्लोराइड, सोडियम पोटेशियम, कैल्शियम मैग्नीशियम करेंगे या दूसरा करेंगे? So what decides that which parameter you will select, right? तो ये भी उस मॉनिटरिंग प्लान का एक हिस्सा होगा जिसमें कि आप डिसाइड करेंगे that which parameter to select for the monitoring. Okay, so there are some common parameter which you need to have it in all groundwater quality monitoring program, right? So ये वो कुछ main water quality parameters हैं. Although you can increase it depending on your objective. For example, if you want to trace petroleum contamination, if you want to trace, for example, heavy metal concentration in your study, so in case as the effectiveness of any monitoring program is visible in the number of parameters selected for the monitoring, right? Now, as you increase the parameter, you will increase the accuracy, right? अब यहाँ के ऊपर how many parameters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we just took 12 parameter, and here we miss out some very important parameter in the form of heavy metal and bacteria. Heavy metal and bacteria, right? So depending on the requirement of your monitoring plan, you can go on increasing the parameter into your sampling plan. ठीक है, तो सैम्पलिंग प्लान की जो पैरामीटर्स होंगे वो किस पर डिपेंड करेंगे? वो जो आपका ऑब्जेक्टिव है आप सेलेक्ट करेंगे कि आपको क्या करना है, बेसिकली बेंचमार्क क्या है, फिर उसका लैंड यूज पैटर्न क्या है, वहां पर पेस्टिसाइड्स हैं तो पेस्टिसाइड का इम्पैक्ट भी हो सकता है. If you have some landfill in your area, then you need to include some more parameter by looking at the landfill or the nature of waste in the landfill. So this way you go on strengthening your sampling plan. Now from this list, selecting only station that measure parameter consistently on an annual basis. This is to reduce the redundancy that you will take the continuous data set. Okay, what next? You will go for water quality index. Water quality index is a simple and concise method useful for indicating impairment of water quality. Water quality helps for the better management of groundwater quality issue, of course, and also it is important uh, in a way that it provides you a numeric value so that you can classify your groundwater type into with the help of some numeric value, and you can classify it into different categories, right from excellent to very poor. Okay, so Canadian Water Quality Index is one of such widely applied, statistical technique to analyze the water quality index. इसमें 3 कंपोनेंट होते हैं. फैक्टर 1 which is scope. फैक्टर 1 में क्या है? नंबर ऑफ फेल्ड वेरिएबल्स, यानी जो सैंपल और जो पैरामीटर हैं उन्होंने फेल्ड हो गए हैं अपॉन टोटल नंबर ऑफ वेरिएबल. फेल्ड से क्या मतलब है? नंबर ऑफ फेल्ड वेरिएबल. Let me tell you. For example, pH. What is the WHO limit for pH? WHO limit for drinking water, right? Yes, anyone? pH की क्या यानी acceptable range है?
I think 6.5 to 8.5.
6.5 to
8.5.
तो आपको इसमें कितने सैंपल फेल्ड लग रहे हैं? कितने सैंपल्स? I think only one.
सर ये 8.6 हो रहा है.
8.27 is fine because 8.5 तक range है, right? Range is from 6.5 to 8.5. Right? If this is the range, and make sure once if this is the range, then we can say only one sample is failed. And how many total? We have 1, 2, 3, 4, 5. 5 out of 5. Out of 5, we have one failed, which is this, right? Going back. So this is how number of failed variable, total number of variable into 100. Number of failed test, total number of variables. Okay, so this is how the frequency is defined. Failed means failed the criteria. Criteria of what? Criteria is the guideline, either taken from WHO or your country have your own guideline. So with that guideline, you will compare and you will find out whether it is failed or passed. So if it is failed, you will bring it into this equation. And factor 3 is amplitude. Amplitude defines that how, by what magnitude it is failed. I mean, for example, the limit for TDS is 500. Okay. Limit for TDS is 500. Now 407 is passed. All these are failed. Right or wrong? I'm audible?
Yes, sir, right.
Okay. But you can still see that 478 is close to 500. Right? So this will not be as bad as 2659. ओके सो इनका भी डिफरेंशिएशन होना चाहिए कि नहीं होना चाहिए? यानी ओके मैंने कह दिया ये चारों सैंपल फेल हैं, ऊपर वाले जो दो कंपोनेंट थे विच इज फ्रीक्वेंसी एंड स्कोप, इसमें ये बात कवर हो गई दैट दीज 4 आर फेल्ड. बट ये थर्ड फैक्टर जो है इसमें ये वाली बात को हमें हाईलाइट करना है कि ये चारों फेल तो हैं, लेकिन चारों का फेल होने का तरीका अलग है. यानी जो हाउ फार दे आर एक्चुअली फ्रॉम द ये डिजायरेबल और व्हाट यू कॉल द क्राइटेरिया. राइट? ये जो 500 है इससे कितना फार है आपका वैल्यू इन द सैंपल. So of course 2659 will be farthest. I mean ये सबसे दूर है इससे. So this will be the best. This will be the bad one. But this 748 will be relatively fine, right? So वो उस वाले फैक्टर को यहाँ पर हाईलाइट करने के लिए we have I mean these Canadian have introduced factor 3 which is amplitude, right? अब इन तीनों का जमा इस तरह से कैनेडियन वाटर क्वालिटी इंडेक्स के फॉर्मूले में ये हम रख करके कैनेडियन वाटर क्वालिटी इंडेक्स निकाल लेते हैं. दिस इज वन ऑफ द वाइडली एक्लेम्ड एंड वर्ल्ड वाइड यूज्ड. तो ये हमने लास्ट टर्न पर हमने यहाँ तक बता दिया था. राइट? यू गो ऑन to find Canadian water quality index model free download or something, you will find that you will have some Excel sheets which you can download and you can have your data, customize your data and even compute. So data will look like this, and you will have criteria. First you will have variable, for example you have conductivity. In conductivity for drinking you can have the limit, right? For conductivity you can place your limit. You can customize that lower and upper. If you have both, for example in case of pH you have both, so you will write both, or if you have just upper you will write upper. So this way you can customize your objective. Okay, so these objectives, what are these actually? These are nothing but the criteria. अब क्राइटेरिया कौन सा है? WHO का है कि यूनाइटेड स्टेट्स का है कि यूरोपियन यूनियन का है, या आपकी कंट्री ने सब जगह से लेकर के अपना एक डेवलप कर लिया है? राइट? सो व्हाटएवर इट मे बी दैट यू विल राइट डाउन हियर. अच्छा, इसमें और क्या स्पेशलिटी है? यू कैन ऑल्सो यू नो डू वाटर क्वालिटी इंडेक्सिंग फॉर अदर ऑब्जेक्टिव्स. अब ऑब्जेक्टिव कहना यहाँ पर सही नहीं होगा, इसलिए कि ऑब्जेक्टिव हमने दूसरी जगह कहा है. दूसरे यूजेज के लिए, मसलन ड्रिंकिंग वन यूज हो गया, एक्वेटिक, रिक्रिएशन, इरिगेशन एंड लाइव स्टॉक. तो ये सारे यूजेज आप इनकी ऑब्जेक्टिव डिफाइन कर लें. मींस जो इनकी WHO लिमिट है या जो भी स्टैंडर्ड्स है वो यहाँ डिफाइन करने के बाद में यू कैन रन थ्रू द डेटा, और आप अपना ये इस तरह से किसी भी सॉफ्टवेयर में आपको एक एक्सेल फाइल बनानी होती है, उसका जो फॉर्मेट है वो आपको उस तरीके पर डिजाइन करना होता है जिस तरीके पर सॉफ्टवेयर उसको एक्सेप्ट कर ले. ठीक है? वहां पर सॉफ्टवेयर कुछ कंडीशंस होती हैं, that you need to put x and y, latitude and longitude. You need to put the z value in certain column, so that you need to always check, and it is true for any software, right? Software की जो वर्किंग फाइल होती है, वर्किंग फाइल को बनाने का एक खास तरीका होता है जो कि उस सॉफ्टवेयर के साथ कंपेटेबिलिटी होती है। तो वो आप उस तरीके पर उस फाइल को बनाते हैं। सेव करने के लिए भी बहुत सारे सॉफ्टवेयर्स में ये होता है कि यू हैव टू सेव इट इन अ सेपरेट फोल्डर, राइट, एंड यू हैव टू क्लोज इट वंस यू आर रनिंग द सॉफ्टवेयर। तो इस तरह की कुछ कंडीशन सॉफ्टवेयर्स ले डाउन करते हैं, वो आपको माननी पड़ती है। फिर आप सॉफ्टवेयर रन करते हैं, सॉफ्टवेयर का पाथ उस वाली फाइल से जनरेट करते हैं, देन एक्चुअली द सॉफ्टवेयर विल वर्क। Okay, but this is true for any software. Okay, now इसके बाद next वाला जो है वो relative weight method है। Relative weight method में we actually assign weight for different parameter. For example, ये सारे के सारे पैरामीटर्स हैं, pH, EC, TDS, K, Na, Ca, Mg, Cl, SO4, bicarbonate, fluoride, nitrate. Now इनकी importance with respect to human health will not be same. Okay, this, although the assigning weight is a subjective concept, but to get more accuracy in our result, we do this. We have this method which is called in which we have this weight assigning weight to different parameters. Okay. अब weight के बाद there is a formula actually. QI, which is quality rating, is equals to CI over SI times 100. Now CI is the concentration of each chemical parameter. जो chemical parameter की concentration report हुई है वो आप यहाँ लिखेंगे. SI is the standard value for that. Okay, for example TDS. So TDS में आपकी observe हुई CI 1000 और standards का कितना है 500. So 1000 divided by 500 times 100. ठीक है? Then next step में आप क्या करेंगे, जो ये QI है उसको आप multiply कर देंगे WI से. WI is nothing but weight for TDS. I यहाँ पर TDS है. हमने यहाँ I आपको 1000 बताया, वो TDS का बताया, ठीक है? So WI is nothing but weight factor for TDS. अब ये दोनों को मल्टीप्लाई करने के बाद में हमारा ये SI आ गया, SITDS यानी इंडेक्स ऑफ TDS. अब टोटल वाटर क्वालिटी इंडेक्स के लिए हम सारे के सारे SIs को, SIs हैं बेसिकली इंडेक्स ऑफ TDS, सोडियम, पोटेशियम, क्लोराइड, बाइकार्बोनेट, उन सब को यहाँ पर ये समेशन का साइन है. समेशन में दैट ऑल पैरामीटर्स आर एडेड अप. अच्छा, ऐड होने के बाद में if the value is less than 50, this is excellent water. If the value is ranging from 50 to 100, this is good water. Poor water, very poor water. So this way we can categorize our samples by percentage of samples, that 10% of my samples are in excellent category, good category, poor category, and from here we can strengthen our monitoring plan, or we can go for wellhead protection also. So many things we can do from this. Okay, any question at this moment? Now, next is unique weight method. Now, unique weight method may unique weight method is slightly different than this relative weight method. This is slightly in a different formula where SPI is number of sample passed upon total number of sample for I. That I is 1 to n. So 1 could be TDS, 2 is sodium. So this way all parameter will be analyzed individually and then finally they will be summed up. Okay. So I will, share the notes. Hopefully, you will go through these notes, and if you find any difficulty, water pollution in relation to water use. So, what is groundwater pollution? So, we'll start with the basic definition, and it is very simple. Anything that alters the naturally occurring groundwater quality through contamination and place it into unfit category for a specific usage, it termed as groundwater pollution. Now, groundwater pollution and groundwater contamination are synonymously used term, but there are slight difference. So, if you can think of the difference, contamination is not always leading to the pollution, right? That is a slight difference, but in most of the literature, you will find that both the terms are synonymously used. Pollution would mean that it is making it unfit for that specific use. Although contamination would mean that it is increasing the concentration of that specific parameter, chemical parameter in groundwater. And if more contamination, this event of contamination may equalize or may qualify to be called as groundwater pollution. Okay, you got my point? The primary pollution of groundwater results from substances that naturally occur in groundwater and the mineral environment, or by all types of point and diffuse source of pollution. And that is why groundwater should be protected and regularly monitored. So here two terms came up. One is point and one is diffused source of pollution. So what is point and what is diffused source of pollution? That we will go through. Generally, groundwater contamination is the result of human activity in areas where population density is high and human use of land is intensive. Groundwater is especially vulnerable to contamination. Right? Any activity whereby chemicals or waste may be released to the environment has the potential to pollute the groundwater. Since groundwater and surface water are connected, pollution of surface water will indirectly impact groundwater quality. Okay. So when groundwater becomes contaminated, it is difficult and expensive to clean up. Okay, you agree with this or you want to argue? Groundwater how to purify the contaminated groundwater. So as I said, with regards to its origin, there are two categories of pollution in terms of source. These are point pollution and non-point pollution. Point pollutions are those which are easy to identify. I mean, उनकी genesis को identify करना आसान है. You can easily identify, not easily, but it is relatively easy to identify the point pollution. As the name suggests, it comes from a single place. Now, non-point pollution are harder to identify and harder to address. It is pollution that comes from many places all at once. Right? So, कुछ clear हो रही है बात point pollution and non-point की? Okay. With this pictorial diagram, you have a big residential complex, right? You have a number of septic tanks, you have sewerage system, so you will have leaks from this bigger area, right? So it is difficult to identify which housing complex or which specific house is leading to this contamination. So this is called non-point pollution. Although in the same area there is a single factory, one factory, which is having some harmful effluent, and that very nature of that effluent is introduced into the ground. So it will be easy to identify because the source is single. So and another example of non-point source is, for example, you are in the agricultural tracts. So agricultural tracts are large and they are, large in area, right? They are having similar type of activity. For example, fertilizer अगर वो apply कर रहे हैं, so most of them they are applying fertilizer or pesticide. So the activity is taking larger area and uniform pattern. So that will be called non-point, because it will be difficult for you to identify that actually which field or which part of the area introduced this nitrate or some other pesticide into groundwater. Okay, so this is how point and non-point pollution is addressed. So with this I end up the class. We will